I want to talk a little bit about Venn diagrams. Doing Venn diagrams, again, you should have been exposed to these already. We make a rectangular box, which is the universe, which contains everything. Then we start putting circles on there, and we label them. We'll call that A, and we'll call that B. And so what we have is something that is neither A nor B. We have something that's A but not B. We have something that's B that's not A. And we have something that's both A and B. Now, if you look at that, it should look familiar to something else we've been working on, which is truth tables. So if we did a truth table of A and B, this would be false, false, true, and false, right? This is neither A nor B. This is A but not B, so you couldn't say A and B. This is the only area where it's A and B. Now, in Venn diagram, when something is true, or you're talking about that area, you would shade it in. So this would be A and B. Right? And again, we can use the and, or we can use a dot. And so we have the area shaded in, and you would not need the F's, because if it's not shaded in, it would be a column. Now, if you think about the last line in the and truth table, it's true, false, 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 right? That's the last line, because we have A, B, let's fix that up. True, false, false, false. And we have A and B, true, true, false, false, true, false, true, false. And it's true, false, false, false. This single column is the same as this Venn diagram. Now, the other interesting thing is, if we did this as 1, 0, 0, 0, this is now a binary value. So a single binary value can be the result of a truth table. So you can represent the value of a truth table in a simple binary value. Of course, you would look at it either as 1, 0, 0, 0 or 0, 0, 0, 1, depending on the type of system you're working on. So it'd either be 8 or 1. So you can see the connection between Venn diagrams, truth tables, and binary numbers. Now, we're doing ands and ors, and we're doing if we're doing sets, instead of ands and ors, we do unions and intersections, but they're ands or ors. And of course, it's A union B and A intersect B. And that would be the same as the intersect is the and the union is the or. So that's A or B, A and B. So if we can see the connection between sets and the truth tables, we can see the connection between sets, truth tables, and Venn diagrams, and binary. So everything all works together, which is why we're learning all this. Now, it gets even better. You can also make that connection between databases, a relational database model. In the relational database model, we have tables, and each of those tables has some primary key value, and we can put them together where all the elements are connected, which would be an or we can put them together where only they match up. So if we have 1, 2, 3, 4, and we have 3, 4, 5, and 7 as our key values, if we were doing an or, it would be 1, 2, 3, 4, 5, and 7. If we were doing and, it would only be 3 or 4. And so the connection between all of this we're working on connects even further into databases. So if you've taken database, you can hopefully see the connection between doing joins in databases. And if you haven't taken database, when you're learning joins, you can see the connection between this and doing joins in databases.